So, welcome one and all. In this lecture, I will discuss more about random variable and probability distribution. But before that, there is a concept of Bernoulli trial in statistics. So, what is a Bernoulli trial? Bernoulli trial is a random experiment which results in exactly two possible outcomes. What is a Bernoulli trial? It is a random experiment which results in exactly two possible outcomes. One of these outcomes we generally refer to as success and another as a failure. Okay, prior. Now, the Bernoulli trial or this experiment, it has the following properties that there are only two possible outcomes. One of them will be success and another failure. And the probability of success, P, usually we denote by P, the probability of success in a single trial. The probability of success in a single trial is constant. Okay, no matter how many times we conduct this Bernoulli trial, but the probability of success, it must be same, constant throughout. Okay, and it should be known. The probability of Q, actually, what is Q? Q is 1 minus P, the probability of failure. Even it is also constant throughout all the trials, and the trials are independent. Okay, meaning the outcome of one trial doesn't affect the outcome of the another. Now, examples of Bernoulli trials, for example, flipping a coin, because either we get head or tail. Suppose if I get my head, then I can term it as my success. And obviously, in that case, what will be tail? Getting a tail, it will be my failure. Okay. Yeah, we can define vice versa, means if I am getting head, then I can term it as my failure. Okay. And obviously, in that case, getting a tail, it will be my success. It will be my success. Okay. Now, if we roll a die, if we get an even number, we can call it as our success. Even number means 2, 4, 6. And if we get a odd number means 1, 3, 5, we can call it failure. And vice versa means if we get even number, then it is our failure. And if we get an odd number, then it is our success. Similarly, drawing a card from a deck of card. So either the card will be a ace card or a non-ace card. Either it will be an ace card or non-ace card. Okay, we may define in this way also that either it will be a spade card. Okay, either it will be a spade card or non-spade card. Okay, non-spade card. Okay, so there are many ways to define these two outcomes, means with our success and failure. Okay, so if we get ace, we call it our success, and if it is non-ace, then it is our failure, or vice versa. Okay, so actually, in the cards, basically there are four suits. One is hearts, the suits of hearts. Then there is clubs. Okay. Then there is diamonds, diamond. Okay. And there is one more hearts, clubs, and then this what we say. Just wait. Wait, please. So there are four suits in case of cards. One is hearts, okay. Another is clubs. So hearts, they are actually of this type, obviously, and they are red colored. Okay. Club is like this. It is black colored. Okay. And then diamond is of with this suit, and spade. So there are basically four suits in the cards. So hearts. So I was telling you that this hearts looks like this. Clubs, this one. Diamonds, and there is another one that is spade. So spade is this one. Okay. Actually, spade and clubs, they are black colored. Okay. and hearts and diamonds, they are of red color. And each suit has 13, total 13 cards. Okay. And obviously there is a ace card in each suit. Okay. The number one card. The number one card, that is called the ace card. Then we have another one, that is number 11, 12, and 13. So 13 is king. Actually, jack, queen, and king. The jack, queen, and king. Okay. And this one is ace. So this is number one card. This is 11, 12, and 13. Okay. Now, even conducting a medical test, either the report may be positive or it may be negative. So if the report is positive, then this we can term it as our success, and if it is negative, we can term it as our failure. Okay, so these are what we call, these are some examples of Bernoulli trial. Now, this Bernoulli trial, it is named after the very revered personality, Mr. Jacob Bernoulli, okay, a Swiss mathematician who studied probability theory in the 17th century. So now, based upon this, we have very interesting questions which are here. So this one. So actually, Bernoulli trial is conducted until first success appears. Okay, means we are conducting the trial, the Bernoulli trial, until our first set success appears. And once the first success appears, we stop. Once the first success appears, we stop. Now, what is X here? Denotes the number of trials required to get the first success. Okay, so here what values this random variable can have, actually this x, if I write here this x, it can have value 1, start from 1, then 2, then 3, then 4, and it will go on. Okay, because quite possible in the very first trial, because what is x here? Number of trials. Please mind, what is x? Here it is the number of trials required for the first success. Okay, required for this. So here I write here x is number of trials. Okay, required for the first success. Now, quite possible in the very first trial, I got my success, then I will stop. And what is the meaning of X2? Means in the first trial, I got failure. In the first trial, I got failure. And in the second trial, I got success. What is the meaning of X3? In the first two trials, I got failure. In the third, I got success. What is the meaning of X4? That I got three failures in the first three trials, and in the fourth, I got success. So here it should be success only. Okay, so this is the meaning. Number of trials which are required for first success. And now we have to calculate the corresponding probability of x equal to x. So here it is probability x is 1. Okay. Then probability x is 2. And going on. Now, what is the probability of x1? Probability that there is one trial for first success means the probability of success itself. The probability of success means first trial. We conducted the Bernoulli trial for one time, and that one time we got success. Okay. So here, what is the meaning of this? Probability of x equal to 1 means we conducted the trial for first time, and first time we got success, and obviously we stop. Now, what is the probability of this success in single trial? That is P. Now, what is this probability? Probability of x equal to 2. This is nothing but probability of F and S. Means in the first trial, I got failure, and in the second trial, I got success. In the second trial, I got success, and then after that, I stop. And this is nothing but probability of F into probability of S. Why so? Because all the trials are independent. Okay, so if the two events A and B are independent, then probability of A intersection B the probability of A and B. This is nothing but probability of A into probability of B if the two events are independent. So same here. Now, what is the probability of failure in a single trial? That is nothing but Q. And what is the probability of success? It is nothing but P. Now, the probability of x equal to 3. So what is that? It is nothing but probability F and F and S. Okay. So what is this now? It is probability of F into probability of F into probability of S. Once again, now we are applying this fact that the trials are independent for three events. Okay. And now this is nothing but Q. Even this is Q, this is Q. So Q into P, that is nothing but Q square P. And I think one can very well see that this probability that x equal to 4, which is nothing but probability F and F and F and S. This will be nothing but Q cube P. Okay, and going on. So here what we have here P. Here what we have Q into P. And in the next what we have Q square P. And in the next what we have Q cube P, Q cube into P and going on. Okay, so these are the probabilities. Yeah, one thing, my tables are not proper, means the lines are not that straight one. Okay, but in your exam, please do take care of these table that it should be constructed properly. Now, once again, if I give this symbol, say fx, okay, then you see here that summation of fx over x equal to 1 to infinity. So what will be that? It is nothing but p plus qp plus q square p and here q and going on. Okay, and now here it is take p common. So 1 plus q square plus q cube and going on. And now what is this p? And look at this series now. This series is an infinite GP. This is an infinite GP. So its sum, it will be A upon 1 minus R. So what is A here? A is the first term, which is nothing but 1. So I will write 1. And what is R? R is the common ratio. So what is the common ratio here? It is Q. Okay. And obviously this common ratio Q, it is less than 1 because Q is also a probability. Q is probability of failure. So that's why it is less than 1. Okay. So here it is 1 minus Q. Now what is this thing? P. And what is 1 minus Q? It is nothing but P because P plus Q is equal to 1. So what we get? 1. So the sum of all values of the PDF, okay, this probability distribution function, the sum of all values of PDF over entire range of X, the random variable, it is always equal to 1. And moreover, for all values of for all values of x, the random variable. Okay, so for all x, this is never negative. Why? We can very well see p, q square p, q p, all these values, they are never negative. Why? Because this p and q, they are always greater than equal to 0 and less than equal to 1, because ultimately P and Q, they are the probabilities of success and failure respectively. Okay, so this is one such example, and there was another example also. Just wait, please see here. Yes. Now here, actually, this example and this example, they appear same, but please mind, they are not same. Actually, in both the examples, Bernoulli trials are conducted until we get our first success. But in this example, what was our random variable? Number of trials required to get the first success. In the very first example, our random variable was number of trials for the first success. But in this example, what is X? It is the number of failures. It is the number of failures to get the first success. Please mind, I repeat, in the first example, the random variable was number of trials, okay, for the first success. But in the second, it is number of failures, okay, for the first success. Okay, so once again, we have to find the values which this random variable can assume, okay. Now, the things will be almost same. The only thing that this x now, okay, so I write here. So this x, so here, this x, this its value, it will start from 0, then it will be 1, then it will be 2, then it will be 3, and so on. Because now what is x? It is the number of failures. It is number of failures for the first success. It is for the first success. So, what is the meaning of x0? Actually, here it is nothing but our success. Okay, so here how many failures are there? How many failures? There is zero failure. Yeah, if I define x, the number of trials, if I define the x, the number of trials, okay, for the first success, for the first success. So here, when it will be the first success for the first success, for first success, obviously I have to conduct trial at least one time. For first success, I have to conduct the trial at least one time. So if you have observed, for this x, the value started from 1. The value started from 1. But for this x, this random variable, for number of failures, okay, so for this x, the values will start from 0. Okay, then what is the meaning of x1? Okay, for this example, now here, actually, what is this case? X is 1. Actually, this case will be failure and success. Means I have conducted the trial, Bernoulli trial, 2 times. First time I got failure, okay, and second time I got success, so I stopped. Now for this one, how many failures are there? How many failures are there? One failure. But how many trials are there? Two. The trials are 2. So I repeat here, for the top one x, for the top x, okay. Here for s, the value of x was 1. And for this, the value of x was 2. But for this x, the below one x, here for this event, for the first success, here it is 0 and here it is 1. Okay. And now what is the meaning of this x2? Okay, it will be nothing but F and S. So here, how many failures? How many failures for the first success? Two failures. Okay, so here for the lower x, for this x, what is the value of x? 2. But for the same event, what is the value of upper x? It will be 3. You can very well see that this x, it is 1 starting from 1, then 2, then 3, because this x was number of trials for the first success. But now this x, it is number of failures for the first success. Okay, so ultimately the things are almost same. So if I have to calculate this probability x is x, okay, so basically probability x is 0. Okay, what will be that? Nothing but probability of success. Yeah, this will be again nothing but p. Now probability of x equal to 1. This will be probability of f and s, okay, which will be nothing but q into p. Then probability of x equal to 2. that is nothing but probability of failure and success. Okay, which will be nothing but sorry, it should be Q square P. Q square P. Okay. So, this case where our X is a number of failures required to get the first success. I'm talking about this. It is also sometimes it is also written as that X denotes the number of failures preceding the first success. I write yes. So X is number of failures, number of failures preceding preceding the preceding the first success, preceding the first success. How many failures precede? Okay, so how many failures precede the first success? Okay, but ultimately the probabilities will be same. The only thing, the values of the random variable. For the first case, the random variable starts taking values from 1, but for the second case or example, the random variable starts taking from 0. Okay. Now, these two examples actually they are just like homework for you. Now here, what is our Bernoulli trial? It is nothing but coin is being tossed. Coin is being tossed until head appears. So here, getting a head, I may term it as success. I may term it as success. And X denotes what? Number of tosses. Now, what is a toss here? It is a trial here. So any toss is our trial, which is resulting in exactly two outcomes. Either it is head or failure, and if it is head, then success. So here, what values X can assume, you can very well do, and find the probability distribution of the same number of tosses. Okay, for the first head. Okay, so actually, this is just the previous case. I am leaving it as a homework for you, and then obviously here, what is P? P is 1 by 2, and Q is also 1 by 2. Okay. And what is this case? Here, once again, the coin is tossed until head appears. Now, what is X? It is number of tails. And what is getting a tail here? It is our failure. It is our failure. So here we have what is our random variable? Number of failures for the first success. What is X here? Number of failures for the first success. So this is just corresponding to the second example. Okay. Now, obviously here P and Q both are half. So these questions, they are just homework for you. So do try these, and if possible, comment on these two, on the solutions. Share as much as you can share the solutions of these two questions. Okay. And then we have one more example, which is here. So here there are two teams, Team A and Team B. They are playing a series of three matches. And what is X here? It denotes the number of wins in three matches by Team A. Okay. So this X, what values it can have? This can have either value 0, or it can have value 1, or 2, or 3. Means out of the total three matches played, out of the total three matches played, the team A, it can win no match, 0 match, or team A can win one match, or team A can win two matches, or team A can win all the three matches. Because what is X? Please note down what is X here. The number of wins in three matches by team A. By team A. So here either team A will win a game or a match, or team B will win. Okay, so here the concept of tie is not there. The concept of a draw or tie is not there. So either team A will win a match or team B will win a match. So in a certain sense, even this question is also a case of Bernoulli trial. Here, what is our success? Our success is if the match is won by team A. If the match is won by team A, then that is our success. And if team B wins, then that is our failure. Okay. And now here, these are the values of x, and we have to find this probability x is x. And obviously, this is probability x is 0, probability x is 1, probability x is 2, and here this. Now, probability x is 0. So, what's the meaning? That all the three matches, they are lost by team A. Okay, so lost by team A, first match, lost by team A, and lost by team A, the three matches. Now, obviously, the games are obviously all the matches played are independent. So this is probability of loss. Actually, I should write here probability of loss by team A, LA, loss by A. So if it is lost by A, then won by B. So it is probability this and this one and nothing but this. Now, what are these? Actually, this is nothing but Q into Q into Q. Okay. Because what is the probability that team A loses the match? Okay. It is Q. Because if team A is losing the match, then obviously team B is winning the match. Team B is winning the match. And what is the probability of team B winning the match is Q. Natural thing that P plus Q is nothing but 1. So here all the three matches, they are won by team B. So that's why this is Q Q. Now, probability x equal to 1. Actually, this will be probability of two matches, uh, one, two matches won by team B and one match won by team A. So if I write like this, so here I will write 1A. Means here team A, it has won only one match. It has won only one match and two matches they have lost. Okay. Now, this one actually it will be probability LA, probability LA and probability WA. So what is LA? Team A lost the match. Okay, and what is WA? The team A has won the match. Now this will be nothing but Q into P, basically Q square P. Okay, so this X equal to 1, its probability is Q square P. But please mind this one match, this one match which is won by team A. It can be any of the three matches played. Suppose match one, match two, match three. There are three matches played. So in this case, I have taken that third match. The third match, it is won by team A. The third match is won by team A. But this single match, it can be M2 also, the second match also. Means we can have this case that LAWA and LA. We have this case also. And moreover, this single match, it can be first match also. Means it can be WA, LA, LA. Okay. So basically, what are these? These two, they are the permutations of the same combination. What combination? That two matches lost by A and one match one match won by team A. Okay. So this combination, it has uh, three permutations, and about these I have discussed in the very first lecture on random variable. Please do watch. I have discussed in very detail. So all these three, means this one and this one and this one, they will have the same probability. But will be that probability? Nothing but Q square into P. So what is this total probability? This probability that x is 1. It will be this probability plus this probability. So what will be the answer? It will be 3 times q square p. 3 times q square p. Now, similarly, what is this probability? Probability that x is 2. So this is now, so probability x is 2. So means two matches are won by team A. So this is one such case is LA, WA and WA. Okay, means first match is lost by A, but the next two they are won by A. But this will be the case WA, LA and WA, and this WA, WA and LA means the first match, okay, M1 lost by team A, but the next two matches they are won by team A. And here the second match, this is lost by team A, but the first and third they are won by team A, and I think this is clear. Now all these actually they will have the same probability, that will be QP square. Okay, so QP square, QP square and QP square, that will be 3QP square. Just apply the same logic that we have applied here. And now the probability that x is equal to 3, the probability. So the probability that x is 3, what will be that? So here 1 by A, 1 by A, 1 by A. So this is a probability, this one. Okay. So this is now actually P cube. Okay. So these are the probabilities. And now here, obviously, so here probability x is 0. So its value was q cube. I write here, I show you. Yes. So q cube. And what was this value? It was 3q square p. And this value, it is 3p square cube. Okay, and this value is p cube. And now if you add all these, what will you get? Nothing but q plus p whole cube. Okay, means a cube plus b cube plus 3a square p plus 3ab square. And what is this thing? It is nothing but 1, because p plus q is 1. So 1 cube is 1. That is once again verifying that this summation of these fx, if I denote it by fx, okay, that this summation of fx over entire range. Okay, so this is nothing but summation of fx over x0 to 3. This summation, it is nothing but 1. Okay, this we may write once again that this is also summation x0 to 3, which is probability that x is x. Okay, and fx is obviously non-negative for every value of x. You can see, because all the values of fx, they are p cube, 3p square cube, 3q square p, okay, and q cube, and they are non-negative, because p and q, they are non-negative. Now, if by chance here nothing is mentioned about, if in the question nothing is mentioned about the probability of winning for any team. For example, here I have mentioned, this is mentioned that P is the probability of winning by team A, winning a match by team A. Q is the probability of winning a match by team B. If no such mention is there, then by default we will take that P and Q both are equal to half. Both are half means both the teams have equal chances of winning the matches. Okay. Thank you. Thank you.